Hello, my name is Budimir Bogićević. I'm working in software company in Join from Belgrade as senior software engineer and line manager. In my lecture today, I will look at some, perhaps unobvious things on which the Elastic full text search is based. Elasticsearch is the most popular search engine, and the number of users is increasing every day. It can significantly improve the performance of your application, especially if you work with large amount of data. We will start with a few basic concepts. Documents are considered the base unit of storage. Document is a serialized JSON object that is stored in Elasticsearch under unique ID. In the world of relational database, the document corresponds to table row and field corresponds to table column. A document consists of one or more fields. On the other side, index is the largest unit of data in Elasticsearch. It consists of one or more documents and can be compared to database in relational database terminology. In Elasticsearch, we use index as a verb and noun. Document is indexed into an index. There are a variety of ingest options for Elasticsearch, but in the end, they all do the same thing: put JSON documents into an Elastic index. You can do this directly with a simple put or post request that specifies the index and document ID you want to add. If no unique document ID is provided, Elasticsearch generates one for you. If you index document using ID that already exists, the new document overrides the existing one. If you have a lot of documents to index, you can submit them in batches with the bulk API. Using bulk to batch document operations is significantly faster than submitting requests individually, as it minimizes network round trips. Elasticsearch is horizontally scalable and very fast. This second feature is based on the fact how data is stored. When you index a document, it is being passed through three steps: character filters, tokenizer, and token filters. Structures called analyzers are responsible for processing text in Elasticsearch. Analyzers can be viewed as a pipeline that takes text as an input, breaks it into terms, and returns the terms as output. The character filter receives the original text as a stream of characters and can transform the stream by adding, removing, or changing characters. The tokenizer receives a stream of characters, breaks it up into individual tokens, usually individual words, and outputs a stream of tokens. For instance, a white space tokenizer breaks text into tokens whenever it sees any white space. Each analyzer must have a single tokenizer. And token filters add, delete, or modify the tokens created by the tokenizer. Analyzers have zero or more token filters. There are many predefined token filters. Some of the most commonly used and most popular token filters are stop token filter, lowercase token filter, and stammer token filter. Stop token filter removes stop words from token stream. When not customized, this filter removes English stop words by default, based on list. For example, words the, is, if, in, on, etc. In addition to English, the stop filter supports predefined stop word lists for several languages. Lowercase token filter changes token text to lowercase. And stammer token filter provides stemming for several languages. Stemming is the process of reducing a word to its root form. For example, walking and walked can be stemmed to the same root word walk. For instance, the document to be or not to be, that is the question, may be actually stored in two different ways. The first example is on the left side, if punctuation marks are removed and all terms are lowercase. That's not the end. It can be as well stored as just question. If the stop word filter is applied, which removes all common language terms like to, be, or, not, that, is, and the. So, this is the indexing part. But the same steps are applied when searching for documents. The query is being as well filtered for characters, tokenized, and filtered for tokens. Then, Elasticsearch is searching for documents with normalized terms. There are so many predefined Elasticsearch analyzers, but the default analyzer in Elasticsearch is Standard Analyzer. Standard Analyzer has three main features. It has no character filters, uses the standard tokenizer that works based on grammar, and tokens are generated based on grammar. It lowercases all tokens and optionally removes stop words. A field can be analyzed with multiple analyzers to achieve different goals, built-in or custom analyzers. For instance, it can be analyzed with simple or stop or snowball analyzer or some of language analyzers like English or German analyzer. When the built-in analyzers do not fulfill your needs, you can create a custom analyzer, which uses the appropriate combination of 0 or more character filters, one tokenizer, and 0 or more token filters. Of course, the results from the analysis are indeed stored somewhere, within something called an inverted index. The purpose of an inverted index is to store text in a structure that allows for very efficient and fast full text searches. When performing full text searches, we are actually querying an inverted index and not the JSON documents that we defined when indexing the documents. Inverted index consists of a list of the all unique words that appear in any document, and for each word, a list of documents in which it appears. Thanks to inverted index, Elasticsearch can immediately return matching document IDs instead of having to evaluate every document. For example, let's take a city name field in document with ID 1. If the field contains text New York and an analyzer creates a term for each word, the corresponding inverted index would contain two terms, New and York. Both these terms would be mapped to ID1. When fields are queried in a text search, document matches are determined by terms in the inverted index. For example, if the text search is Delhi, the document with ID 3 will be returned. Importantly, text search matches are not determined by the contents of document JSON, only by the terms in the inverted index. Text to text analysis and inverted index, Elasticsearch can serve results times faster than regular databases. Therefore, inverted index is great for search, but based on this structure, it is very difficult to do sort by specific field. In fact, if you look at the structure of the inverted index, it is seen that it's impossible to sort documents by city name field. But Elasticsearch can create second data structure out of your documents, called doc values. Doc values exist only for keyword fields, not for text. This structure is used for sorting and another type of search, aggregations. The main purpose of Elasticsearch is to provide a search engine. The goal is to serve the best matching documents. But how does actually Elasticsearch know what are they? How many irrelevant documents are returned? How well are documents ranked? In Elasticsearch, we can measure search relevance by following parameters: recall, precision, and ranking. By default, Elasticsearch ranks matching documents according to the score it calculates. Recall measures how well a search finds every possible document that could be of interest to the search. Recall has less influence on user satisfaction than precision. Recall is particularly important in applications where the user cannot afford to miss information. For example, such kind of security and compliance applications. Actually, recall is measuring as the ratio of true positives versus the sum of all documents that should have been returned. True positives plus false negatives. On the other side, precision is an important measure of search effectiveness. It is the ability to filter out irrelevant hits and focus on potentially useful information. Of course, precision can be difficult to measure in absolute terms because people have subjective opinions of search results. And precision is the ratio of true positives versus the total number of documents that were returned. Instead, in the other words, true positives plus false positives. And very important term in Elasticsearch is score. For every search query, Elasticsearch computes a relevance score. Once the results that match are retrieved, the score they received will determine how they are rank ordered for relevance. Default scoring algorithm in Elasticsearch is BM25. There are three main factors on document score: term frequency, inverse document frequency, and field length. Term frequency is: the more a term appears in a field, the more important it is. Inverse document frequency is: the more documents that contain the term, the less important the term is. And of course, shorter fields are more likely to be relevant than longer fields. If we analyze term frequency and analyze dependence on the frequency of term occurrence in the field in relation to the score, we can see on diagram, we can see that the curve rises sharply somewhere up to 7 or 8 occurrences and then flattens out. We can make the similar diagram for inverse document frequency. As far as the IDF is concerned, it is observed that the score decreases sharply with the increase in the number of documents containing the term, whereby after about 200 documents, the score almost becomes equal to 0. That was the sum of the most important terms in Elasticsearch. How we can increase precision during searching? Precision can be improved by making searches more strict, using queries that only return exact matches. But of course, in that way, we will have worse recall. Take match query as an example. Match query is simple but powerful search. The default operator for match query is OR, and in our case, this is the search that finds all the documents that have text or analyzes in the field content. Or logic can be changed to AND with slightly different syntax for match query, and precision is improved, but recall is decreased. Let's try text analysis search using match phrase instead of match. The match phrase query is for searching text when you want to find terms that are near each other. Now, precision will be much better. Of course, recall is much worse. But two things must happen. Text and analysis must appear in the content field, and the terms must appear in that order and next to each other. If you want to increase the recall of match phrase, you have to introduce some flexibility into the phrase. It is parameter called slop. In our example, the slop value of 1 lets any additional word that appears together with text analysis show up in the search result. And results will include phrases with intervening terms. When a user searches for something, it is not always known what the context of the search is. That is, to which field the search relates. The multi-match queries provide a way to accomplish this. In our example, we simply added 3 fields that we think might contain search terms. In this case, we can also improve precision using match with phrase. There are also other ways for improving precision, with combining queries using Boolean logic and bool queries, or using filters. In today's world, we expect the search application to grant some flexibility in terms of precisely matching. Elasticsearch is capable to deal with misspelled words using fuzzy queries. Fuzzy queries are one of the most powerful features available in Elasticsearch. It allows to search for similar terms across thousands of documents on an existing index. Fuzzy matching treats two words that are fuzzily similar as if they were the same word. Fuzziness property refers to the number of character modifications, and we can add a level of fuzziness to our query is in our next example. The match query has a fuzziness property, and it can be set to 0, 1, or 2, or can be set to auto. In our example, we have a case when in match query, one character in the search term is changed from text to test. We see that there are no documents as a result of the search. But in that query with the wrong term, we can add fuzziness level equals 1 and get a lot of hits. As I mentioned, auto is the preferred way to use fuzziness. It defines the distance based on the length of the query terms. When I say distance, I mean level of fuzziness. How auto works? If the length of the query term is 0, 1, or 2, the maximum level of fuzziness will be 0. In other words, only terms with exact matches will be returned. If the length of the term is 3, 4, or 5, the maximum distance allowed will be 1. And if the length of the term is greater than 5, the maximum value of fuzziness level will be 2. Fuzziness is a very popular and easy solution to handle misspellings in your data, but has some limitations like high CPU overhead and very low precision. There are some better ways to handle misspellings in the queries that user type. For example, autocomplete or suggestions functionality that compensates for misspellings while the user is typing, and some advanced text analysis techniques. We already mentioned some text analysis techniques today. Search is something that any application should have. Now, Elasticsearch has great full text search with a lot of functions and possibilities. It's impossible to even mention everything during this time, let alone explain in detail. But for this occasion, I have chosen to follow what is happening with the documents we store in Elasticsearch, starting from their indexing to searches. We mentioned how documents are indexed in Elastic. what happens during the text analyzing process, and what is the role, and what do analyzer consists of, how inverted indexes are built, and why Elasticsearch can find data much faster than relational databases. We also touched on how Elasticsearch ranks documents, and how it calculates the score and what factors influence it. We also mentioned which parameters we need to pay attention to if we want our search to be more precise. We have shown how to improve precision and or recall on several examples using different combination of match, match phrase, and multi-match queries. Finally, we touched on the fuzzy query as one of the most popular features of Elasticsearch. And that's it. I hope that I have brought you a little closer to some features of Elastic Full Text Search, which is at first glance are not obvious. Thank you for the patience you had to listen to me. If you have any questions, suggestions, or comments, do not hesitate to send them by email.